GMAT all day.
Now let's take a look at that same VAC question that we just solved algebraically, this time using a testing numbers approach, because I am frequently testing numbers on the GMAT, especially in VAC questions, and VAC questions are a good opportunity to practice your testing number skills, because testing numbers really is a skill, just like learning any other concept on the GMAT and learning any other approach to solving a type of problem. When you are testing numbers, you have to be very organized, and you have to make sure you are keeping track of the numbers that you are testing. So with VIC questions, even though I said algebra might be my preference, I do not always see, there might not be an algebraic way of doing certain types of VIC questions, or I might not see the algebraic way of doing a VIC question. And so in those cases, I really have no choice but to test numbers. And testing numbers should always work. There should always be a way of testing numbers. It might not be the most efficient way, but it is always good to have as a backup option. And so you don't want to be testing numbers for the first time on your actual test. And so when I am reviewing a VIC question after I've taken a practice test, regardless of how if I got it right or if I got it wrong, whatever my strategy was on the test, I try to see if I can do it the other way. So if I did it algebraically, I see if I can test numbers and vice versa. So let's see what testing numbers looks like here. So same question. Felix can build a fence in X days. Oscar can build 1/3 of the same fence in Y days. Together, they can build 2 fences in Z days. What is Y in terms of X and Z? And so what I am doing here when you are testing numbers is I am choosing numbers for Y, X, and Z, and then I'm using those to calculate the answer. In this case, I'm trying to find what Y is in terms of X and Z, and then I have to plug in. So I have to plug in my choices for X and Z into my answer choices, and then choose the one that spits out an output of Y. So when I plug X and Z into my expressions here, which one gives me a value of Y? And so the one thing you need to be careful of when you are testing numbers or when you are choosing numbers, and sometimes people refer to this as choosing smart numbers, you want to choose numbers that are going to make your life as easy as possible. So I wouldn't say that necessarily means there's a single optimal set of numbers, but if you can try using numbers that will be easy to work with, that is good. But you also have to be aware of dependencies. So it's not as easy as just picking anything you want for X, Y, and Z, because you still have to understand something about rates. And so if you understand that this is a combined rate problem, well, Z is part of their combined rate. So the value for Z is going to depend on the values you chose for X and Y. So in this case, it's sort of like you can choose numbers for 2 of the 3 variables, but then the third one, you are going to calculate. You're going to have to calculate because it is dependent on whatever you chose for X and Y. And so when I choose numbers, so Felix can build a fence in, let's say, 5 days. And so we'll say X is equal to 5. And when I am choosing my numbers, I star them, I box them off, because I'm going to have to retrieve them later and plug them in here. And I'm going to have to remember what those numbers are. And sometimes it is easy to forget, as we will see here. Oscar can build 1/3 of the same fence in Y days. Let's say Oscar can build 1/3 of the same fence in 2 days. Y is equal to 2. Together, they can build 2 fences in Z days. So remember, I cannot just choose any value here for Z, because it's just dependent on my values for X and Y. And so even when you are testing numbers, you still need to understand what you are doing, what the underlying concept is. So for example, here, we can fill in our chart in the same way we did before. We can't plug these numbers in. So if Felix can build a fence in X days, that means his rate is 1 fence every 5 days. Oscar can build 1/3 of the same fence in 2 days. So 1/3 of a fence every 2 days. That is the same as 1/3 times 1/2, which is 1 fence every 6 days. And then together, the rate will be 1/5 plus 1/6. But I need to make sure, remember, Z is not their combined rate. Z is just the time component. So I have to get the rate in terms of 2 fences in order to find what Z is. And so their combined rate is going to be 1/5 plus 1/6, which is a common denominator of 30. So 1/5 is 6/30 plus 5/30, which is 11/30. So this is their combined rate. So if I want to find Z, their combined rate is 11 fences every 30 days, which is a perfectly normal way to express a rate. If I want to find Z, I just need to find how long would it take them to do 2 fences. That will be my z. So z should be equal to 2 over 11 30ths, or which is the same as 2 times 30 over 11, which is just 60 over 11. So that is my z. Now, I said before that you want to try and choose smart numbers, and usually that means choosing integers. Here, we tried to do that. I thought I was choosing good numbers with 5 and 2, but then that resulted in a fraction here. But when this happens, I do not panic. I do not scramble to re-choose new numbers that will work out, because if you're comfortable working with fractions, this should not be that big a deal, especially because when you are plugging into your answer choices, you don't have to go all the way. If you see an answer choice is obviously not going to make sense, for example, we need a value of y that is equal to 2. So if you see that even when you plug in this fraction here, you're going to get a negative number, for example, you don't have to solve that. You can eliminate that answer choice because there's no way it's going to give you a value of 2. So these are the values that I am plugging in. And this is why I said before, when I am testing numbers, when I choose those numbers, I star them, I box them off, because even though Felix's rate is 1/5, 1 fence every 5 days, I am not plugging in that 1/5 into my equations. My x is still equal to 5, and my y, in this case, is equal to 2, not Oscar's rate, which is 1/6. And the same for the combined rate. The combined rate is 11 fences every 30 days, but my z is 60 over 11. So now, when I am actually testing my numbers that I chose, maybe let's do this on a new page. X is equal to 5, y is 2, z is 60 over 11. X is 5, y is 2, z equals 60 over 11. So they are asking for y in terms of x. So they're saying when I plug 5 in for x, 2 in for, when I plug in 5 in for x and 60 over 11 in for z, which one of these choices gives me a value of 2? That is y. So starting with the first answer choice. And so even though when I'm choosing smart numbers, I try to avoid numbers such as 1 or 0 or any number that's going to result in a 1 or a 0 in my numerator or denominator, because when that happens, even though you might think that those are the easiest numbers to work with, you are increasing the probability that you are going to get 2 or more answer choices that are going to give you the same output, which you don't want to do, because when that happens, then you have to retest those choices, or more likely, because you'll probably be running out of time, just sort of a guess between them. So I always try to choose easy numbers that are still unique, because then I am decreasing the chance that I will get multiple answer choices with the same outcome. And also because of that, because as long as I am confident that I chose unique numbers, when I do get to the right answer, I do not then test the remainder of the choices to make sure they don't give me the same answer. Once I get the right choice, I stop and I move on. So in this case, if we just start with the first one, so when I plug in 5 for x, that's 60 over 11 for z, we get xz, 5 times 60 over 11, over 6x, which is 6 times 5, minus 3z, so minus 3 times 60 over 11. So this would be 300 over 11 up top, over, so 30 minus 180 over 11 on the bottom. So if I want to just combine my guys on the bottom, I need a common denominator of 11. I multiply this by 11 over 11. 11 times 3 is 33, so 11 times 30 should be 330. We have 300 over 11 all over 330 over 11 minus 180 over 11. So 330 minus 180 should be 150. And now I am pretty happy because I see I have an 11 here and 11 here. They should cancel out. So I have 300 over 11. So 300 over 11 divided by this fraction here is the same as multiplying by the reciprocal. So multiplying by 11 over 150. These 11s cancel out. I get left with just 300 over 150, which is equal to 2, which is what I'm looking for, because that is my y. And so A is the correct answer. You can test the rest of the choices if you want to make sure they don't give you a value 2. But like I said, when I'm taking a test, once I get the outcome I'm looking for, I stop and I move on. A.